All right, welcome everybody to our first ever LinkedIn Live event. Just a disclaimer, this is the first time we're ever trying this platform out, so we're kind of beta testing it. And what we want to do is essentially just start off by having just a conversation about really network challenges and how we could overcome these challenges, especially with these challenges we're seeing with technology today. So uh, I thought the best person to have this conversation with would be someone who actually designs the tools for people who are designing these networks. So get a good perspective from Isam. I'll let him introduce himself.
Hey everyone, my name is Isam Chaudhry. I'm the senior product owner at IBWave. I'm responsible for driving the roadmap around all of our core products, IBWave Design, Mobile, IBWave Reach. And so, yeah, I'm excited to be here on this platform and looking forward to a great conversation here.
Okay, and I forgot to introduce myself. Well, my name is Nazim Chaudhry. I'm responsible for market development. So I've been in IB Wave for about 12 years now. So supporting different clients, OEMs, carriers, enterprises directly. And right now I'm focusing on just the broader market and market development. And a lot of my questions are related to also what we're facing and what our clients are facing today, really with along the lines of the complexities of these future networks, these 5G networks and such. So what I want to do today is just really start off the conversation with Isam, and then we're going to open up the conversation for everyone else. But just to get the ball rolling, what I want to start off with is when I personally think of the challenges of 5G networks, I start thinking about the use cases that we're trying to solve and the complexity of solving those use cases, because the use cases we're seeing, especially in the private network spaces, are related to mining, manufacturing, industry 4.0, and these are very complex environments. So my first question would be to Isam, what are your suggestions to really simplify modeling these very complex environments, or simplifying just deploying your network in these complex environments? And especially when you also take a look at the technology, when you're looking at 5G technology, the frequencies are very sensitive towards different types of materials. So it's a big challenge getting the environment right, but also being able to have the right amount of simulation. So my first question would be around, how do you get the environment right, especially when it's a very complex environment? Think of like a data center, a manufacturing plant. There's metal everywhere and such.
Yeah, that's a great question, and I think you pretty much touched on really what the challenge is here, right? Being able to model those types of environments in enough detail so that you can capture basically the all of the nuance around that wireless behavior, the behavior of RF in that type of challenging environment with that type of complexity. And so, yeah, in those cases, it's very important that we do model those type of environments with all the detail that's needed. I mean, you mentioned things like manufacturing plants, warehouses. I mean, think of all of the equipment, all of the racks and shelves, and just everything that's involved in those type of layouts, and needing to model those accurately in those environments is crucial, right? Especially as you mentioned, we're talking about higher frequencies like millimeter wave, or even frequencies in the higher range of the sub 6 gigahertz. So yeah, that type of precision is important, and you know our our users are wanting to find ways to simplify that type of modeling. And so in response to that, I believe has introduced some functionality that I think is really exciting, and it's the Stencil Library feature, which kind of allows users to model those 3D objects and elements in the level of detail that they need. They're able to then capture those combinations of objects and walls and surfaces with their various textures and their various RF properties, and uh, stencilize those, meaning keeping those in a library where they're handy and they can be used across projects, and just user can quickly drag and drop an entire warehouse rack into their design and place it and easily scale it to size according to the floor plan measurements. And so, you know, uh, you mentioned different types of verticals that make use of those, of our software to do their designs. And, some of them have very typical layouts, very typical, objects and elements that they need to include in their designs. And, the Stencil library allows them to, eliminate some of the painstaking aspects of modeling those elements that need to be incorporated into their simulations, into their predictions.
Okay, understood. And so I guess I'm wondering if there's any limitation to what you can stencilize, like especially when you look at verticals, you have to start incorporating, like let's say you're in the runway of an airport, maybe a plane, or if you're working on a design in transportation or in subways, like a train as an example, or even an entire subway subway station, or even an entire tunnel. So yeah, I guess my question is there an extent to what you could stencilize?
Uh, no, no extent in terms of 3D modeling. As I mentioned in IBWave, these 3D objects consist of any combination of, horizontal surfaces, inclined surfaces, and vertical surfaces, also known as walls, right? So any combination of those three elements can be combined to form any of these complex objects in IBWave. So if you can model it in IBWave today, you can store it as a stencil to be reused across projects. It's kind of like you model it once and you have it there in your library forever that you can continue to use it across all of your projects. And we also make it possible to share those stencils with your colleagues, so that you can all collaborate and make sure that all of your designs have that same richness and that same level of detail.
Okay, understood. So I guess that kind of leads me to my next question. So we're building these complex designs and we're incorporating all these different types of materials, different racks. We're talking about airplanes and cars. So I guess my question, and you also talked about sharing stencils and sharing projects. So my next question would lead to, in these complex type environment, complex projects, is it not getting very the isn't it is it not getting very extensive? The file size, are they not getting very extensive? We're putting in so much detail just to be able to replicate the environment, but is that not creating an extensive amount of data that's going to be hard to work with and hard to even like perform all these simulations and calculations that we want in that project, and even to share? And a lot of these projects are always shared between different parties, going from SIs, OEMs, and carriers. So that would be my next question. So we're addressing the complexity, but are we making another side of the equation even more complex by making it a very extensive file size?
Yeah. Yeah, I think that's kind of the crux of the conversation we want to have today, right? So we have our users who need to find the balance between the level of precision in their designs, the level of accuracy that they need, and balance that with the speed of uh, the speed of the design process, right? Their efficiency. You know, Ideally, you have a tool that allows you to fine tune that balance according to your use case, according to the different requirements of your application. Um, all the verticals that you mentioned, right? They all have their unique requirements. They all have their unique um, uh, um, KPI criteria, right? So, uh, an ideal solution lets you manage the balance between speed and performance rather than having to sacrifice one for the other, right? So, if you're doing, for example, a high level design or a very initial preliminary design, or maybe you're doing kind of trying to get a rough order magnitude out. You might reduce some of the complexity there so that you can get something out very quickly, and you can, uh, you can get a package out for approval as soon as possible, right? But then you can also get into situations where you need the utmost precision and the utmost accuracy, and at that point, you're having to model with with extreme detail. You're having to run many simulations, a lot of predictions, a lot of what if scenarios, making tweaks and tuning the design and rerunning the maps. And um, it's just a wide range of a wide range of combinations that need to be tuned to get that balance between performance and accuracy. And they're both important in their own right. And so, I think, as you mentioned, in cases where we start adding all of that detail and all of those objects and elements into the analysis, of course, the way our prediction algorithms work and the way most prediction algorithms work will take into account when computing those simulations will take into account all of the details in that environment. And so, it's important that as we introduce that capability to have that level of detail in the 3D modeling, that we offset that complexity with increased performance in the software. And so, that's kind of why, I think in the invite to this LinkedIn Live event, we sent some information about some ongoing performance improvements that we've been doing here at IBWave. It's taken up, we've dedicated a lot of our bandwidth over the course of last year towards optimizing the performance of our software. Um, uh, and of course, it's an ongoing process. We continue to invest into the performance there. But just as an example, right? What we've done to kind of uh, enable our users to have that level of detail in their designs, we have to then allow them to also achieve better performance with the software, right? The time it takes to run link budget calculations, the time it takes to run predictions, right? So we've optimized those two engines significantly, right? So I want to say in the order of, in extreme cases, where the link budget calculation was previously taking, uh, you know, almost hours. We've reduced that by about 98%. And and on average, we're seeing about 60% reduction in the time it takes to run those calculations. Um, Predictions, we've seen on average about 30% reduction in the time it takes to run predictions. We've also, in extreme cases, seen cutting that time in half. So those type of improvements in our software that we continue to incrementally introduce into our tools is what's going to then enable our users to tip the balance in favor of accuracy, right? Accuracy and detail-oriented, rich designs that get that level of precision that our users expect and need. But aside from engine-wise, we've also have to manage things like the file performance in general, right? The time it takes to load and open files, the time it takes to save a project, and then of course ultimately the file size, right? The space on disk of those IBWave design files. So also significant optimizations have been made in those areas as well, to the point where by enabling users to save the link budget calculations along with the file, they're now able to load that without having to rerun calculations, and kind of now can get the design open in front of them in 10% of the time it used to take, right? So reduce that time by about 90%. So all of those optimizations that I mentioned, right, those were all in that effort, right, to make sure that our tool continues to allow users to get that level of detail that they need.
No, absolutely. Thanks for the answer. I guess my question would be, um, how were you able to achieve all those optimizations? I guess, was there a new technology involved, and what really differs from the past years where we've been slowly, incrementally optimizing the performance? What made it so drastic this year around? Was it a new technology, or was it a
Yeah,
drastic change in methodology? Or yeah, sorry.
yeah, I think it's a shift in focus, right? I won't get into the whole philosophy behind, trade-off between product and feature development versus technical debt and technology. But it's really IB Wave actively deciding that we're gonna focus our bandwidth on performance, and we had formed a tighter team of experts in our software who really dove into the code and made all the optimizations that could be achieved, and through that we're able to achieve some of these really tremendous results. And as I mentioned, right, a lot of those improvements were completed by the end of last year, but it's ongoing. In fact, we have some really exciting improvements on the way as well. We're looking at right now in very near future releasing hardware accelerated predictions, which is going to take prediction speed to the next level. We're talking about you leveraging the GPU along with the CPU that is typically used to generate predictions and run those simulations. But that GPU acceleration, we're seeing already very promising results. We're expecting that sometime mid this year to achieve somewhere in the order of 2 to 3 times faster predictions.
Yeah, that's great. And in my opinion, personally, improving the speed of prediction is one of the best features for improving accuracy, because at the end of the day, it gives you so much more bandwidth to perform more predictive analysis. So in many cases, you may have a very complex venue and you only may have the capacity to spend 5 days on prediction. And just by accelerating the prediction speed, that could maybe, like you mentioned, if we take it down to half, that gives us twice as more bandwidth to do much more iterations and really focus on tweaking the design to meet those levels of accuracy. So that's really great to hear. What's also great to hear is just improving modeling. So as technology is being more complex, it's becoming easier to model as well. So that's very essential, in my opinion, and it's essential for just the overall accuracy of designs for this future 5G technology, because the way we're seeing the industry moving, it's going to be very use case oriented. And when you look at use cases, they're in these factories, they're in these mines, they're supporting users who are not humans anymore, so like robots and devices. So I believe it's all very important. So these are all great to hear. I think I asked enough of my questions, so I'd like to open it up for the to the audience as well. And to the audience, it doesn't have to be IB Wave specific. It could be technology specific, and we're going to try our best to answer to the best of our capacities. So I'm going to jump into the comment section here.
Yeah, so I see one question here asking about the new hardware specifications or requirements that are going to be needed to stay up to date with the tool. I think that's coming from Ron. Thanks for the question, Ron. So those details are on the way. As I mentioned, once we have that hardware acceleration ready to release and make that generally available, they will absolutely come with our recommendations for different tiers of performance that you want to achieve. So those details will certainly be available once that feature is ready to be G8. We're currently running benchmarks right now using different GPUs, different hardware configurations, and we're gonna come out with our recommendations to our customers so that they can most effectively leverage that hardware acceleration. Okay, I see another question here from a LinkedIn
so
user.
we have another question here.
Sorry, Nazim, go ahead.
Go ahead. No, you go ahead.
Okay. So another LinkedIn user here. How can prediction plots be efficiently generated in IB Wave for a large-scale project like a resort featuring multiple sectors overseen by different operators? For one of my projects, the task involves running all predictions. It takes at least 14 days, covering approximately 4 million square feet and deploying a neutral host system with 12 sectors. So what tips and suggestions do we have for streamlining this process and ensuring accurate results? Yeah, those type of extremely complex venues and huge campus style projects we're seeing a lot of now. You know, uh, Obviously, as you increase the size and footprint of the area that you need to predict on, you'll start seeing situations like you mentioned, taking 14 days to run predictions. That type of square footage, I would say, is not typical in building design, but it's certainly a valid and relevant use case, and for which we've introduced our campus design tool, IBWave Reach. So IBWave Reach allows you to kind of generate predictions on the outdoor and incorporate a lot of the outdoor network modeling into design, which is really intended to address that campus, large scale, 4 million square feet type of area. Now, obviously, on the in-building side of that, at that point, it does involve, starting off perhaps with high level estimates and trying to run designs through some functionality that we've introduced called edge calculations. So edge calculations allow you to kind of create your network design from the edge, right, from the remotes onto the front end of the DAS, and kind of put aside the head end for now, run those calculations, run those predictions, and kind of then understand the coverage that you need to achieve, and then start building the head end behind that, the edge calculations. And so, obviously, a type of enormous project like that will certainly have its own set of challenges. Some users will break up the design into different areas, different buildings, and have multiple design files to cover those different areas. So yeah, it is a challenge certainly for that type of large scale design, but I would recommend to look into our campus solution, which is really ideal for those type of large indoor outdoor type of venues like a resort. Okay,
Yeah,
and
and
then another.
just to add on to that question, one thing that you did touch upon as well is kind of taking an iterative approach in design accuracy. So in the very beginning, where you're looking for maybe high level estimates, really focus on a lower resolution or higher resolution actually. No, sorry, lower resolution. So if you lower the resolution, your prediction speeds will be faster, but obviously it'll be less accurate. So kind of take an iterative approach, lower resolution to start it off, and then as you're getting closer towards the end of your project, start using higher and higher resolution until you're at your final design. You feel confident in it, and then put it at the resolution to your client's requirements or their KPIs. They typically have maybe a 4 resolution or 6. So don't start off at 4 and 6, because that's gonna mean it's gonna take a lot of time to do every single one of your predictions. And the other approach you can take is you could leverage your prediction. We have different prediction types, and you could use a faster type of prediction in another area. If you have like an open space environment, you could use a different zone using a different prediction model that is much quicker than the physical empirical model of fast ray tracing.
Yeah.
So I
Okay.
think we have another question here. It's about the complexity of network design also depend on the technology deployed. So I would say it really depends more on, it does depend on the technology, but it also depends on the environment. But a lot of designs we've been seeing in the past haven't been like these millions of square footage that you're talking about as well. Well, there has been for stadiums, but the complexity comes when it's a combination of the environment and the technology deployed, because you have to look at the equipment you're using and if it suffices for the environment that you're trying to cover. And while you're putting those balances together, the environment and the accuracy, that's when we start seeing these different types of complexity. If you had complex equipment in a small environment, the challenge isn't that bad. If you have a big environment with very easy to use technology, maybe it's like a parking lot. So again, it's not that complex. It's really when you tie both the complex technology and the complex environment, that's when these challenges really start to arise. And I'll let Isam
Yeah.
touch on that as well.
No, I agree. It's certainly a factor of those two, things that you mentioned. But also, I think in the question also mentions, the different type of uh, vertical or use case, even right, public safety, for example, which I think, here we're talking about designs that involve public safety, right? And involves safety of first responders that are responding to emergencies in a venue. And I think in those types of use cases, there's no room for concessions on accuracy, right? And you have very stringent compliance criteria that you need to meet, and it's something that we take very seriously as well, especially given the fact that public safety type of designs essentially there's the safety of first responders on the line here, literally. So it's something that I think demands a higher level of accuracy, and in turn involves a bit more complexity. So yeah, I mean, technology deployed, the environment it's being deployed in, but also the use case that is being applied is also a factor.
Yeah, absolutely. So I'm just checking if there's any other questions.
Okay, I see another one here. The Stencil Library is a great feature, and I've used it to create a couple of items. It supports the software greatly. In a future release, will we be able to import a 3D Revit model versus 2D AutoCAD and versus reconstructing elements via the Stencil Library? So Matthew Stuver, thank you for that question. Yeah, absolutely. In our product roadmap, we are currently looking into supporting those different, let's call it BIM or IFC formats. And so, you can expect that as part of our roadmap. It will certainly be something that will greatly improve the 3D modeling capabilities of our tools. So you can look forward to that. I think the Stencil Library is kind of a good a good tool, like you mentioned, that you can use in the meantime to help reconstructing those elements, and to help avoid having to reconstruct those elements. So yeah, keep an eye out for more news on the support for those different modeling formats.
Yeah. Okay. I think we have another question here, and we touched it a little bit about it with regards to the technology for improving prediction. So the question is really, is it going to be CUDA-based acceleration? So I'll let you answer that.
Are there any CUDA-based acceleration options available for the various IBWave computations? So we currently do leverage the GPU for 3D modeling, but rather right now those CUDA accelerations are specifically being applied to predictions. Things that just require computation and mathematics. So obviously, there are opportunities to then leverage the CUDA acceleration for other computations, like the calculations and other applications. So for now, the area of focus is the predictions, really alleviating some of the burden on the time it takes to run predictions. And that's where you'll see most of the gains with the CUDA acceleration. But again, as I mentioned, there are opportunities to improve some of the other computations with CUDA as well.
So there's another question about, are there roadmap plans for IBWave to provide a web-based front end with the computation occurring on a Linux server back end? So for the first question, yes, there are plans for IBWave to provide a web-based front end. So that's something that's being worked on right now. So it's really meant to be technology agnostic. So depending on whatever platform you're using, you could access this web-based platform that is currently in our roadmap for development. So I would suggest, and I should have mentioned this earlier, to feel free to connect with us on LinkedIn or wherever. Feel free to add us, and we could answer these questions or dive into more details on these specifics. So just as an example, if you want to learn more about this web-based platform, we could dive into that. Another question. So okay, so this is a big project. So it's 18 buildings for public safety using an active DAS. So I guess very good question. So there's different approaches you could take for this. So I guess there's different approaches. I guess the two things to consider are, you want to show your interconnectivity between all the different buildings, right? So that's one aspect. The other aspect is, I think Isam touched on it, in public safety, you don't want to, there's no room for concessions. You want to make sure that every 18 of these buildings have the right level of coverage. So I guess the first approach that we could look at is, if they're in a campus type environment, Isam also mentioned the best option for campus type environments is using our Reach platform. So that would be the ideal approach. But I would also suggest that when you look at those 18 buildings, you do them individually. So there's really no room for concession. You have the outdoor Reach platform that's going to show you the interference that's coming into those 18 different buildings as you do them individually. So you could take into account the outdoor network or that campus type environment. You could take into account the interference that's coming on the indoor of every single one of those buildings. But I'd make sure that you focus on proper coverage, individually designing those 18 buildings, mainly because you don't want to have any room for error in those buildings. And another aspect of it is the interconnectivity. So we did incorporate an outdoor plan, so that could help you really interconnect all your active DAS systems to the transmitters to essentially spread throughout those 18 buildings in that campus type environment. And I'll let Assam touch on that as well.
Yeah, no, I think that's really it. So as you mentioned, IBWave Reach is one of the use cases for public safety. And we do support those type of use cases as well. So I do think as you mentioned, campuses that consist of 18 buildings, for example, would certainly benefit from being modeled in our campus solution. Okay. See any other questions here? Okay, so what I'm going to do is I think I'll post our LinkedIn profiles here for anyone who wants to connect with us after the call. Feel free to. Oh, looks like I'm not able to post in this chat. So we'll ask our meeting hosts to kind of put that there in the chat so that you can connect with us after the event. There's certainly a lot more to discuss than can be covered in this type of format, but I think it's been a great experience so far, just getting to get our voices out to you all and maybe get the ball rolling on some discussions. And so I think we would invite any and all questions that you all might have so that we can have those further conversations.
Yeah, absolutely. I agree. very interesting session. So again, we were kind of just testing out this platform, but it was a very interesting conversation, and I really enjoyed my time here, and I really appreciate all the questions we're getting. For me, it was a fun engagement with within IBWave as well as with all our audience members as well. So thank you so much for joining, and I'm thanking you guys for helping us test this platform as well.
Yeah, it's been quite the experience. Thank you all.